Hello everyone, welcome to my channel. If you are new to my channel, please subscribe to my YouTube channel, so you can join our tech family. If it is informative to you, please like our video, share it with your friends so they can get help with these video, and don't forget to press all notification bell icon so you get regular update and don't miss our any single video.
Does it really matter if your router has the right time and date? Is it even important in the real world? You bet it is. We're going to take a look at why it's important and how we can have accurate time. Getting the date and time is important, but why? For several reasons. Think about the logs that our devices generate. These logs have timestamps that tell us when an event occurred. Now think about an issue that affects a few routers and switches at the same time. We might need to see events on several devices, so it's important that the timestamps are accurate across them all. And in some industries, it's the law to have accurate logging services. In addition to logging, we also have security applications. Think about certificates which have an expiry date. Or perhaps you've heard about when a Windows workstation can't log into the network because its clock is out of sync with the domain controller. Of course, security services like intrusion detection rely on accurate time, so it can correlate different events to see if they add up to a security threat or not. And sometimes we just want to schedule something, maybe a router reboot which should happen overnight. We wouldn't want that happening at the wrong time or on the wrong day. And that's just networking devices. Other things, like GPS for example, also rely on time being accurate. So we know getting the time right is important. But now let's see how this is done on a Cisco router or switch. One option is simply to configure this manually. First, we'll want to set the time zone with the clock time zone command. For me, that's the east coast of Australia, so I use the code AEST, Australian Eastern Standard Time, and I put in the time offset, which is plus 10 hours. In the state I live in, we also have daylight savings time, which some of you might know as summertime. We can configure this as well with the clock summertime command. I use the code AEDT, Australian Eastern Daylight Time, and now I can set the dates when this starts and ends. Now to set the date and time itself, strangely we have to leave config mode. Here we can use the clock set command, time first and then the date. And we'll confirm this with show clock. One suggestion I'd like to make is if you have devices in multiple time zones. In this case, I would recommend setting them all into the same time zone, perhaps UTC. This makes it easier for us to match up the logs later. So that's how we set the clock manually. Unfortunately, it's a pain to configure on every device. It's only accurate as you and your wristwatch, and it's not synchronized to other devices. So, is there perhaps a better way? Yes, there is, and it's called NTP, or Network Time Protocol. An NTP server is a time source. We configure things like switches, routers, servers, workstations, whatever really, as NTP clients. We still have to configure the local time zone, but the clients now automatically synchronize their time and date with the NTP server. This is very accurate, and it means all our devices can share the same time and date. NTP servers are organized into layers. Each layer is called a stratum. The very top layer, stratum 0, is specialized hardware used to keep track of time. These are atomic clocks that are known to be hyper-accurate. The level under that, stratum 1, is the first layer of NTP servers. These servers will use the time sources in stratum 0 to set their time and date. The next level is called stratum 2, and they synchronize their time with stratum 1 servers. Stratum 3 will synchronize with stratum 2, and so on. Each layer introduces more chances of small inaccuracies in time sync, although to be fair, it's tiny fractions of a second. But to be strictly accurate, the higher the stratum, the more accurate the time source. But practically, what about us? How do these servers fit into our environment? We have a choice to make. We can put an NTP server into our network and configure our devices as clients of that. Or we can use a free NTP server out on the internet. Or we could do a little bit of both. You might already have an NTP server in your network and you don't even realize it. If you have a Windows domain controller, well, guess what? It is an NTP server by default. So you could configure your devices as clients of that server and then configure that server as a client of an internet-based NTP server. Incidentally, NTP uses UDP port 123, so you may need to allow this through a firewall if you're synchronizing with any server on the internet. Now, let's take a moment to see how that's configured. It is quite simple. We use the command NTP server and specify the server that we want to use. Here I've used the IP of a freely available NTP server on the internet. And that's it. Really, NTP is configured. It's done. But we can improve on it a little bit, of course. So first, let's make sure DNS is configured. Now we can set our NTP server to pool.ntp.org. This is, as the name suggests, a pool of NTP servers, so you don't need to remember each specific IP address. There are even regional options. So here in Australia, I could use au.pool.ntp.org if I wanted to. We now have 2 NTP servers configured. So what would happen if we wanted to select one as the primary and only use the other as backup? For example, perhaps we want to choose our internal server as primary and use something out on the internet as a backup if our internal one is unavailable. Well, that's easy too. All we need to do is put the prefer keyword at the end. We can see which NTP servers we have configured and which one we're actively using with Show NTP Associations. The star symbol is the server that we're actively using, while the plus symbol is the candidate server, which will be used if the preferred server does not respond. With Show NTP Status, we can see that the clock has not yet synchronized. The first time the clock synchronizes will take at least 10 minutes, and will use about 6 message exchanges. It does this so the client and the server can measure the time it takes for the messages to pass between them. Remember, some of these servers might be a long way away. And with this, they can work out how to accurately set the time. Once the clock has been set, the client can periodically check in with the server to confirm that the clock is still correct. Unfortunately, I can't really speed this process up for you, so I'm going to have to fast forward the video. And now you can see that the clock is synchronized. The final confirmation is to use Show Clock. You're going to have to trust me on this, of course, but this is accurate for the time I'm recording this video, so this has worked. If you are having trouble synchronizing, which does happen on occasion, I have a tip that might help you. Try manually setting the clock to be close to accurate, and then configure your NTP server. The whole process seems to work a bit more smoothly when the client and the server aren't way out of sync. And as always in this video series, I have a few questions that you can use to test yourself out on and to build your understanding.
We hope you enjoyed the video and found value in the content. We value your feedback. If you have any questions or suggestions, feel free to post them in the comments section or contact us directly via our social platforms. Thanks for watching.